This is exercise 9.2 and question number 3. Find the 15th and nth term for each of the following sequences. In part A, we are given with the sequence with the first term, that is T1, that is 5, T2, that is the second term, that is 7, and so that's why the common difference is going to be 7 minus 5, that is 2. Similarly, you can do it for third and second term. The second term is 9, so common difference can also be calculated by term 3 minus term 2, that is 9 minus 7, which is 2. That means you need to subtract any two consecutive terms. So T1, that is the first term, we normally call it as A. Now since the difference is common, the same difference, so this is going to be an arithmetic sequence. An arithmetic sequence has got the general term or nth term given by the formula a plus n minus 1 times d. Okay, now let me substitute the values. A, that means the first term, that is 5, n minus 1, and the common difference that we have calculated, that is 2. So this will give us 5 plus 2 being multiplied with this as well as with this, 2n minus 2. So 2n plus 3, that is going to be its nth term. So we are done with this thing. The nth term is 2n plus 3. Now we can find out this nth term of an arithmetic sequence in another way. Method 2. Once we have calculated the difference and we have seen that the difference between any two consecutive terms is the same, like the difference between 13 and 11, that is 2, difference between 11 and 9, that is 2, difference between 9 and 7, that is 2, and difference between 7 and 5, that is 2. Every two consecutive terms have got the same difference, so that is why it is known as an arithmetic sequence. Whenever we have got an arithmetic sequence, then the nth or the general term is given by the common difference, and we multiply that common difference by n, and that stands for the number of terms. And now you need to think that if we put n equals to 1, like t1, that will give us 2 times 1, which will be actually 2. From this 2, you need to think that what should be added into this so that actually we get the first term of the sequence, that was 5. So obviously we need to add 3 into this. So this 3 is to be added here, 2n plus 3. So as before, we have got the nth term. The first method was by using this formula of the arithmetic sequence, and the second method is to find out the common difference, multiply it with n, the number of terms, and then add the number which actually generates the first term of the given sequence. So 2 times 1, that was 2. We need to think what is to be added into this to make it 5, the first term of the sequence. So that was 3. So that's why the general term is 2n plus 3. So this is how we need to calculate the nth or the general term. Okay, 2n plus 3. Now I come towards the first part. We need to calculate the 15th term. That means we need to replace n by 15. So that is 30 plus 3, that is 33. The 15th term of this sequence is going to be 33. So that completes our part A and its subparts 1 and 2. Now let's start its part B. We see that 8 minus 3, that is 5. 13 minus 8, that is 5. 18 minus 13, that is 5. And 23 minus 18, that is 5 also. So the common difference, that is the difference between any two consecutive terms, that is 5. So the nth term would be, I'm doing its second part first to calculate the nth term. So nth term is going to be calculated as 5n. Now I need to think, what should I add in 5 times 1 so that its first term should become 3. The actual first term of this sequence, that is 3. So obviously I need to add negative 2 to this. So my nth term would become 5n plus n negative, that is negative 2. So this is going to be the nth term. And similarly, this can also be calculated using the formula a plus n minus 1 times d. The first term is 3 of the sequence, this one, plus n minus 1, and the common difference is 5. Now simplifying it, 3 plus 5n minus 5, which will give us 5n, and plus 3 and negative 5, that is negative 2. So this is the nth term as before, 5n minus 2. Now I need to calculate its 15th term. So I just need to replace n with 15. 75 minus 2, that is 73. That means the 15th term of this sequence will be 73. Okay, now we need to proceed further. Now it's part C. We see that after 3, this is 9, then 27, and 81, and then 243. We observe that each term is being obtained by multiplying 3. Like 3 is the first term, and then this 9 is got 3 by 3 times 3. Then once we have got 9, no, 27 is got by multiplying the previous term with 3. Then 81 is got by multiplying 27 by 3. And then 243 is obtained by multiplying 81 by 3. So each next term is obtained by multiplying 3 with the previous term. So we can say that the nth term would be in this format. If you just see that terms are going to be term 1 and or n. If n is 1, term 1 is 3. Then second term, that is 3 raised to power 2, which is 9. Then the third term is 3 raised to power 3, that is 27. Fourth term is 3 raised to power 4, that is 81, and then fifth term is 3 raised to power 5, that is 243. That means whatever is going to be the number of the term, its form is going to be 3 raised to the power the number of term. So that's why our nth term would be 3 raised to the power n, the number of term. Okay, in the same pattern then, uh, if you just need to see, for example, third term, that will be 3 raised to power 3. That is 3 multiplied with itself thrice, which is 27, and so on. So in the same pattern, the first part would be to calculate T15, and that will be 3 raised to the power 15. When you will have 15 to the power of 3, that will give us, using the calculator, 14348,907. So that is its 15th term. So this is how this part has to be done. Now it is going to be part D. We see that the next term is being obtained by adding a constant term, that is 1.5, because 2 minus 0.5 is 1.5, then 3.5 minus 2, that is again 1.5, then 5 minus 3.5, that is 1.5, and so on. So the nth term would be 1.5n, and then I need to see what I need to add into 1.5 to make it 0.5. So obviously I need to have -1. So that's why my nth term in this part would be this 1.5n minus 1, because this is an arithmetic sequence, because we observed that each next term is obtained by adding a constant number into the previous term. Now for the second part, when I need to calculate T15, that will be 1.5 times 15 minus 1, and this will give me 21.5. So this is how this part had to be done. Now I do its part H, 2, 8, 18, 32, 50, and so on. Now here we observe, if you subtract these two, 8 minus 2, that is 6, then 18 minus 8, that is 10, then 18 subtracted from 32, that is 14, and then this is 50 minus 32, 18. Now you observe that this is the first difference, which is not a common difference in all of these terms. Now what we need to do, we need to check for the second difference. 6 being subtracted from 10, that is 4. 10 being subtracted from 14, that is again 4. And then 18 minus 14, that is 4. This is our second difference. So we observe now that the difference has become the same at the second place, subtracting the consecutive terms for the second time. So this type of a sequence is actually a quadratic sequence. Whenever we have got a quadratic sequence, the general term is being obtained by the formula a plus n minus 1 times d1 plus n by 2 or d2 by 2 n minus 1 times n minus 2. Now let us substitute their values. A is the first term, this one, 2 plus n minus 1, and the first difference was 6 plus d2. The second difference is 4 divided by 2 and then n minus 1 times n minus 2. We can simplify it like this, 2 plus 6n minus 6 and then 2 times n square minus 3n plus 2, and then when we multiply it with 2 you get 2n square minus 6n plus 4, and here this is 6n minus 4. Now we need to see and combine the like terms. Here we can cancel this 6n with this negative 6n, so we are left with 2n square, and then negative 4 gets cancelled out with this plus 4. So the nth term in this case is going to be just 2n square. So this is how you calculate the nth term of a quadratic sequence, which is arithmetic in its sense. So this is the general term of a quadratic arithmetic sequence. Once we have got its nth term, now we can easily find out its 15th term. That will be 2 times 15 raised to power 2. 15 raised to power 2 means square of 15, and then that is to be multiplied with 2. So its answer will be 450. So this is how we had to do these parts.